All right, fair warning, I do not know where my stylus is, so we're doing these notes with my finger, so we'll see how ugly this gets. Today we're just doing more of adding and subtracting. So remember, our big idea is to be able to add or subtract fractions, the denominators have to match, our common denominators. To get the denominators to match, we multiply factors to the top and the bottom of the fraction. When combining the numerator, wow, great grammar. When adding the numerators together, we're going to combine like terms on the numerator, but your denominator stays the same. And remember, I want you to keep the denominator factored. That's something I yelled a lot last class. Keep it factored. So do not multiply your denominator back together once you have it all separated. To be successful, you need to know how to factor, which is what we've been working on. Star, GCF, difference of two squares. You need to know how to FOIL pretty well. I know a lot of you like to use the box method, but being able to shortcut into the FOIL will keep your work a lot cleaner. And then also you need to know how to combine like terms. And these are three things that you've been working on since Algebra 1, so hopefully we're pretty good at this. All right, our first example, combine the fractions. I'm looking at this, my denominators are not the same, so I'm not able to add them together right now. What I notice is that they both have an x in it, but the 4 over x, all it has is the x, where the 2 over 3x has a 3 in it. So all I'm going to do to make my denominators match is I just need to multiply a 3, yikes, to the second fraction. So I'm going to have 2 over 3x plus 12 over 3x. So from this point, I keep the denominators the way they are, but then I do 2 plus 12, which is 14. And don't forget, we like to say our domain. So x cannot equal 0. All right, example 2. Similar, but it's different because I actually have to factor my denominators. My first denominator of x squared minus 5x. It's two terms, but they're not perfect squares, so this is just a GCF problem. So if I take an x out, I'm left with x minus 5. So I'm going to rewrite my fractions as 25, and then x over x minus 5 minus x all over x minus 5. So the denominator of my first fraction has an x and an x minus 5 in it. The denominator of my second fraction only has the x minus 5. So I'm going to multiply to the second one what is missing. So this will leave me with 25 all over x minus 5. And then I'm subtracting x times x is x squared. And then on the bottom, I have x and x minus 5. All right, since this is a subtraction problem, I'm going to turn it into an addition. So I'm going to write this in standard form, so the x squared is going to go in front. All over x and x minus 5. This problem is actually going to have a couple more steps to it because negative x squared plus 25, since my first term is negative, I have to take out a GCF of negative 1. So that's going to be x squared minus 25. And again, I'm keeping my denominator factored. And then I notice I can actually factor x squared minus 25. That's a difference of two squares. All over x and x minus 5. Holy geez, now I notice this will simplify. So I'm left with negative 1 parentheses x plus 5 all over x. So that is as simple as this problem will go. And I just need to add in that my domain is x cannot equal 0 or 5. I'm sorry this is so sloppy. I'm trying my best. So what we did in this problem was we factored our denominators, multiplied something into the second one so that they matched, Then once I added them together, my numerator could factor and simplify down. So that's all we did there. So here you have your two try on your own problems. The first one is just like example 1, to where you don't really need to factor it, but you do need to multiply something in. The second one is like example 2, to where you are going to have to factor them first, then multiply what's missing and go from there. So good luck on these.